is involved. And I managed to get an article accepted into the Industrial Safety Journal just a few days ago about breaching the mining fatalities plateau. And the full title is Financial Pressure, Operational Instability in the Case for Flow-Based Safety. So very happy about that one. And we'll bring some of the ideas across today, not too much. And then at the end of the year, October, there's a big International Mine Safety and Health Conference by AusIMM. So I will be doing a talk there. I have to read off the title because I can never remember it. The Compliance Paradox, Why Operational Stability is the Missing Foundation for Critical Control Management in Mining. And then I will also be talking something similar to today. That will be a recording, Beyond Green Ticks, Human-Centered Method for Evaluating Critical Control Effectiveness. So there'll be overlap there, and I think that's about enough from me.
All right, thanks, Hendrik. So, yeah, there's a bit of work going into, if you like, the science and background around this, but we're going to open up the discussion today just from the 6 elements of due diligence as a framework, because we think this is part of the piece that often gets missed in our thinking around critical controls and their associated hazards and the effectiveness piece. So just going back, the obligations for officers under the Act is this obligation to understand. Now, this is a broad obligation that officers need to understand the nature of the hazards, the strategies that are deployed, if you like, the controls that are deployed to deal with those hazards. But it also requires officers to understand whether those controls deliver as expected or intended. In essence, are they effective? And in doing so, how do they know that they're effective? How is this monitored? How is it verified, and the like? So in our discussion today, we're starting at this touch point, which is a really important, I think, piece to understand in the process. Hendrik.
Thank you, Calvin. So this talk today, I think, was kicked off to some extent by the legislation that's coming in Queensland around mining for critical controls. So it's the Resources Safety Health Legislation Amendment Act 2024. It's been in force now since the 1st of June, and it requires that miners now start implementing critical controls, manage them, but something very different is that the question is now not just do you have a documented system, but does it hold up under production conditions? And I think it's a proper direction to go in from the point of view of the regulator, but of course it makes some things work not so well as they did before and requires us to adjust in other areas. And in this talk, I think you'll see that it's not just in Queensland. There is a trend across jurisdictions there, in the same direction. Thank you, Kelvin. And this is really the test. So if the inspector arrives at the site and he challenges the control effectiveness, so if the question is it reliable in operations? Does it work in practice where people are using it? And with the inevitable performance drift that sometimes happens, how is that detected and can it be managed? Now, this last one, I haven't formally seen expressed, but I assume there's a good chance that this will become important. Thank you, Calvin. And Calvin and I had a chat. I don't know if everybody still remembers the Macondo incident. It's the people that have been in the world for a longer time remember Macondo very well. But it was the drilling rig that blew up in, I think it was somewhere around the Gulf of Mexico, or Gulf of America now, probably. But and if you think what makes that such an interesting case is that according to many traditional assurance systems, as far as management was concerned, everything was going swimmingly. No lost time injuries in 7 years. They had controls for the blowout preventer. It looked great. But what they did not verify properly, and maybe hindsight, it makes it easier for us, is that there were design limitations for the blowout preventer that they did not take into account. There were backup controls that were untested, and human factors were not incorporated into critical operational tasks. And then there were lots of other issues like bad news, not traveling, etc. Kelvin, and then just the next case study. And this is one that's a bit more recent, and I think it's caused quite a bit of distress because the CEO of the Ports of Auckland, I think, was held accountable by the court in a personal capacity for what went wrong. And again, as I say, that seems to be the trend, is that, and in that particular case, if you don't know the background, the court found that although he was exemplary in the amount of effort that he put into safety and in trying to make sure that everything is there, that the processes were active, the court found that he did not do enough to verify that the controls was actually in place and working. So again, it's the same theme that I started off a few minutes ago on. And it's that difference between the work was disclosed to him from the systems and the processes, and the work as done as it actually happened. And that was where the court came down very hard. Thank you, Kelvin. And again, as an aside, something that's not officially, I haven't seen anything officially around it, but I think we all understand that you can have a snapshot of critical controls, and then over time, the situation changes, and that snapshot may not necessarily represent exactly how good that critical control or control is doing the work that it was intended to do. You can read faster than I can speak, but it's just so that you're aware. What makes this tricky is that we're not necessarily dealing with a static once off, I verified it, all is good. Thanks, Kelvin. And then we come with the illusion of the green tick. In the past, it was good enough to say, here are the critical controls, the processes are in place, green tick. Now we have to look at the reality and know that the compliance audit work around the work as it was intended to be done, but it does not guarantee that it's actually being done that way. And then apart from that, we may not be able to detect where the human factors become important. And this often happens where the demand that's made on the cognitive resources, there are peak periods or periods such as during night shift, etc., where it's possible that that's overloaded. And can also be that work is being adjusted at the coal face because of other reasons. Could be production targets, it could be situations that are changing. So a binary review can be blind to what actually happens. Thank you, Kelvin. Oh, I can't hear you, Kelvin.
Going back to old bad habits of COVID, not having a mic on. So I think for me, this has been one of the material things when we look at risk registers in particular, and they're a driving need to demonstrate that when we look at treated controls, that the residual risk is low or very low in that space. And it doesn't take much to look at these risk registers, and I've looked at numerous risk registers and numerous industries over time, is when you look at the control that's been put in place, which is then delivering the mitigated result, the question is, how do we come to that conclusion about that control? And how do we determine that that control was effective? And certainly we made assumptions that the existence of control, and I'll use the examples of administrative controls, that they're effective and material controls, and their presence means that effective control is in place, and that might be supplemented with something else like training, for example. But there was no evidence to actually demonstrate that is the situation, that the control as written and described is an effective control. And this issue has come up in a number of studies over recent years, looking at fatalities in the mining industry in particular, and the level of controls. So the challenge is to shift this perspective, and part of, I think, what we'll talk about today is not being comfortable with green ticks in our control assessments, and trying to present better intelligence to inform the leadership of the business in what decisions that they can rest with, and what decisions that they need to initiate to achieve an acceptable risk within the operational conditions. So this taps a lot into the Holnagel principles, thinking about work as intended or work as disclosed in that space, and the difference between what that looks like and what real work looks like. It is often a much more linear, simple, if you like, process. When we look at the work as intended, we can see that it's sequential, detailed in description, supported by administrative processes and the like. But all of us who have been working out in the field, understand that what happens in the field, particularly in construction's an interesting area. If we take something like a production line in a factory, there often is a lot more predictability about the nature of the work and how the processes function within that. But once we get into things like mining and construction, there's a lot of variation that is coming into place, which often has not been anticipated as such. And as such, we see lots of things like temporary workarounds and things that happen to just things like exclusion zones, for example, being adapted or not complied with in real time for a range of reasons. And that the safety assumptions and features that we've been put in have been regularly bypassed. And we've all done enough incident investigations to see the reality of this that has occurred when the work is done does not match work as intended in the events that we've seen.
Okay, so our goal is to, as safety professionals, is obviously to make sure that the critical controls that are in operation are as good as they can be. And in reality, we probably operate more on the subject matter experts side when we do this work. But there's, of course, the frontline operators, and each of us, in each of those groups, we have a somewhat different understanding of what's going on. On the left, it's the work as intended, more so. On the right, it's more the work is done. And that gap, so there's a consensus area, of course, where everybody agrees. But what we have found out through this process of control effectiveness assessments is that there's some really relevant data that comes out when we compare the views of the subject matter experts with the frontline operators. And we're probably not going to have enough time today to go into that, but that's where we've picked up some significant gaps that between work as intended and work as done, and that's been a very fertile area for improving the performance of the controls. So next slide, please, Calvin. And this is one other aspect that's very important in us trying to get the best critical controls out there and to function as well as possible. So from the Brady report, which is where the Queensland Mining, the latest Amendment Act has gone in. Grady found that when he investigated accidents, about 62% of the controls that were in place were administrative in type or of type. And that's something we should be aware of. And I think the practical implication or the understanding of why this happens is, of course, that we have this gap between the people that know what the issue is the control needs to address, and then a few levels away is the power to allocate the resources. And that's always, in all organizations, that's an issue. Those with the control of the resources are far away from those that feel the pain. And that, to a large extent, explains that somebody dealing with the actual incidents that happen, wanting to control it, they have control over administrative types of controls. They can't do the rest. Now, it's my view that the CEA, Control Effectiveness Assessment, provides support in closing that gap also that goes to the higher levels where the resources are controlled. Thank you, Kelvin.
So in this control effectiveness model that we've been exploring and testing for quite a period of time now, it has numbers or a few areas of focus, if you like. And one of the first things it does, and we'll show you how this fits together, it integrates the energy damage model and the energy pathways attached to the energy damage. I'll come to that in a moment. We do also address the hierarchy of controls and look at how those controls function, but not in a simplistic term. We look at it in a more dynamic relationship. And finally, the human-centered design component of controls is very important, is understanding, getting insight and intelligence and data from the people that do the work and use the controls, and how those controls fit or do not fit with the work that has been undertaken. So we're moving away from the presence controls. You always need to understand whether your controls are present or not, but that is not effectiveness. Once we understand what the controls are, where they exist, we need to then test them in these domains. So I'm just going to touch on the energy damage model because it's become something of more recently a lot more discussion. It's not a new thing at all. So there's a lot of work that's been done by Matthew Hallowell in the space, and I suppose a lot of people would have seen that in the LinkedIn exchanges around this. But the fundamental tenet of this model comes from Derek Viner, which was developed in the late 70s and early 80s, and further developed in the 1990s. But the principles are interesting. So what this model is saying is that, to have an event occur, there has to be sufficient energy that exists to create harm to the recipient. Now, the recipient can be many things. It can be a person, it can be an asset, it can be an environment, a range of different things. And this model simply says there's a number of energies that are to be considered. Derek proposed 12 energies in that space. Understanding what that energy is, what the value of that energy is, so what is the size of that energy, and then considering the space-time transfer of that energy is the other key to this space. Is how is the energy contained or not contained? How is it separated, in essence, from a recipient in that space? And then if it does reach a recipient, is understanding what is the energy threshold that the recipient is able to absorb, and how can that energy threshold be increased to protect the recipient from a damaging energy. So that's a fundamental principle. So in the control effectiveness, this is part of one of the key parts of the considerations, is getting to understand the nature of the hazard that sits within there using that model. And that then brings us into the hierarchy of control. Now, what I think which has got lots of strengths and weaknesses, but it's part of our obligations to apply the hierarchy of control in a number of pieces of legislation. So this sort of approach comes in around the design thinking is, you know, when we've looked at this energy, can we get rid of it? Can we reduce its value? Are there engineering systems and controls that we can put in place? And then we have the elements of human dependency that sit below that, is that what the humans need to know and do and be competent in to be able to put the control into practice and sustain that control in place. So really, in the control effectiveness model, the key to this is you need to understand the nature of the hazard. You need to understand the energies and the transmissions of those, and then you need to understand the interdependencies of human factors and the control, and how these things work together, and what they depend upon to be able to function effectively in that space.
Okay, so I think this is just a bit of a background for the following part of the discussion, but obviously if we are going to look at controls, we need to have a good guideline to quickly identify what's not a control. Now, I think the ICMM has got detailed flow charts, but this we found is good enough for a rule of thumb, and I'm going to let you read quickly through that. But really, in principle, the issue is that procedures, training, and competencies are not controls. And every now and then, we do find that people see them as controls. We see them as control supports. Thank you, Kelvin.
And before I just jump off that slide, in any discussion we have a group of safety professionals, that can be a heated and long debate. So I'm sure there's different views on this group, but we're just coming out of this from a human-centered design perspective.
Yep. And just going back then again from the what was considered good enough under the old dispensation, is the documented system present? Now we have to answer, does this control hold up under live production conditions? Which I think is a very good change. That should be the question. Does it hold up under real production conditions? On the left, for the verification, we had the audits, standardized reporting. Now we must engage with work as done to test the alignment and the adaptability that acts on the inherent robustness of the level on the hierarchy of control that we actually have, that we're looking at. And then we used to have the binary green tick. Now we require to actually continuously have an idea as to the reliability and the effectiveness. It makes sense. It's not good enough just to know once off if something is working. Thank you. And Sanat, that's on this call, has gone through one of these processes, but we start with the materially unwanted event and decide on the critical controls, exactly with that energy model. Then we have to ask, what do design and work as done show us about this? This is where we get the subject matter experts and the frontline involved. Then we score on the CAA profile to get an idea of the fragility or robustness across the four, or the strength across the 4 dimensions. And then finally, we can make a decision as to whether it's good enough, can be improved, what's needed. But we have some numbers that we can tie to, and numbers broken down by the 4 quadrants that you've seen. Thank you, Kelvin.
So when we're looking and have built this model around control effectiveness, it has these four domains and 4 components of trying to determine the effectiveness level of the space. We start from robustness of the control. So this is done by subject matter experts. This is their domain. So once we understand this, we look at the control. First, we separate into control and control supports. So we're trying to focus on controls. and then look at what those controls need in control support to be successfully sustained. And what is the dependency on those control supports? So how dependent is control on a procedure or training or competency, or maintenance, for example. So we're looking at that interdependency and realise that that crosses on a number of levels on the hierarchy of control. The next component, subject matter expert look at the human factors. Is there human factors dependency on the control? This can be, it doesn't matter if the worker is fatigued, if they're paying attention or not, so if the control requires a high level of attention, there might be a train driver responding to a rail signal for a locomotive, then that's going to mean that the control has the more potential to fail if it doesn't depend on that being alertness and physical capability. And the second part of this is, from the user's point of view, is how usable is the control? Does it make sense to the person using the control? Is it easy for them to use? Those sorts of things. The next two components are looked at from the workers done, the frontline experts, if you like, the people doing the job, and to understand when this control is in place. Firstly, for me, the individual, does it make it easier or harder to complete the task? Now, and PPE often comes into this space, in that space, and it can sit on both sides of the fence. Sometimes the PPE can be very poorly designed and make it very difficult to do the job, and then other times the PPE is essential to be able to do the job. So it will shift on whether it helps or hinders. And we're also interested whether the controls actually making complete the overall work objective that the team is working on. Does it make it easier or harder? What's been interesting for us in conducting these assessments is where we get a view back on alignment that the control makes it significantly harder to do the job, we find a significant amount of workaround in those controls. So this is informing us of the reality. We might need people to do something that is not what they want to do, but we have to understand the potential is it might not be sustained in all conditions. And the final part of this process is adaptability and how adaptable the control is. So, just to break this down a little bit more, when we talk about the hierarchy of controls, we look at in the robustness, where it sits on the hierarchy, and then its organisational factor dependency. So this came out of the original work done in Western Australia for looking at organisational factors for safety, and a number of these things come into place, like the procedures and the training and what people are provided with, maintenance, those sorts of things. So we look at the interrelationship between those two things, is where it sits in terms of the control being above the line or not, and then how much does it depend on things being below the line. The human dependency is those two factors, is really from a subject matter expert trying to understand the nature of the human interaction with the control. This can be cognitive load, it can be fatigue, it can be physical characteristics, if you like, the posture and working and those sorts of conditions. How dependent is the control on a worker's capability in that? And then, as we mentioned before, what does the user think about the controls in that key insight? So the alignment, as I was touching on before, is very much about focusing on the worker and looking at the control in practice and getting feedback from the workforce about the nature of the control. We often find that this is the most interesting part, and you often get surprising feedback from people. Particularly, Hendrik mentioned before, we get a view from subject matter experts about their view of a control, and also their view of how this is a good solution for the people doing the work. And when we test that in the field, we can often find a very different response from those that actually have to work with the control and find that. And often they'll have ideas about what might be a better way to approach this than what they've been provided with or what they've been constrained with to undertake this task. And the adaptability piece is interesting in different domains. And really what we're saying, and we've actually looked at this when we looked at the same hazard and the same control in the same organisation in different work sites, for example, we get completely different results in this space. So when the environment changes, when there's lots of other factors coming in around our controls are often created in isolation. They don't really consider the complexity of work and all the other things that are happening in that space. So the ability for the control to adapt, and also the ability for the control to recover in the event of a failure. Now, aviation is really good in this space. They're really good at understanding the adaptability and recovery piece. Often in a lot of our workplaces, we're not as well practiced and skilled to think about how we can have controls function in different domains. The end outcome of this has been, from what we've viewed in this space, is that often mandating controls is not the right space. What you need is to provide the work teams with a range of controls and match them to the operational conditions. So have the team be able to interact in that decision and choose what's right for the activity that they're performing at that time. Where this lands, it comes out, it gives you a mapped view of a control. So it will give an overall rating on a scale of 1 to 5 about the effectiveness controls, taking all of these elements into the calculation. And you can see visually plotted on this where it sits on where the strengths and weaknesses of that control. Is it in the robustness of the control? So what that may mean is we need to look at better engineering solutions to shift that up, and that will shift the dynamics of the control. The control might be poorly aligned to the work, and what can we do, again, to look at the control choice or the design or the application, and those sorts of things. So this just gives you a way to interpret and see where the strengths and weaknesses of the control, and give you a view of where that control sits. Now, the difference in this particularly is your control scores get lower in that space. It doesn't mean the control is unacceptable, but what it means is that you have a very high dependency on control supports and human factors. You then got to look carefully at, well, how do you meet those obligations? How do you sustain them? And can you sustain them sufficiently? And that might mean lots of supervision and support and training and all those sorts of things, or does it lead you to thinking there might be a different way that we need to look at this because of the resource demands of this highly dependent control?
Okay, so, and this is just a overview of the process. At the first point is where we are reviewing the critical risks under consideration. You can see the first one is to scope. Then we go across into the discovery with learning teams, the frontline subject matter experts, and we convert that through into analysis jointly again, as far as we possibly can, and to look at how all the parts come together. What is the true control effectiveness when we take everything into consideration? And then the last part is to try and make sure that things are as transparent as possible. Calvin, is there something you want to add on that last?
No, that's good.
All right, fine. So then our goal is to build a defensible due diligence. Yes, we want to keep everyone safe, but it is good to have something that's defensible. And so we have to involve with our compliance. We cannot just rely on the administrative controls and binary audits. That's what we've discussed up till now. And in order to do that, we need to measure what the operational reality is about. And we think that the control effectiveness assessment is a very good way of doing that. You get point values, but you can also drill down into more details to have an understanding of what makes that control tick and where the risks most likely are. And then the final part of it is, of course, to close the gap and to provide information to the subject matter experts in the design of this control from the front line, which under normal circumstances you may not have. So you can have very good subject matter experts that do a really good job, but we can't expect them to understand what the reality is like where people are actually having to use this. So that's what we think this does very well, as it closes the gap.
And Henrik, I think when you go through this process, particularly in having the interaction with subject matter experts and frontline workers, it's the narrative that is the most valuable piece that comes out in this. What people tell you and inform you about is often, and often it provides subject matter experts with insights that they weren't aware of or hadn't anticipated in that space. So the narratives are the most powerful component of the control effectiveness.
It's the it is the I think it's one of the major positive impacts of this methodology is just that it the way in which it bridges that work as intended and the work as actually done. I think that's a major bridge in helping to bring that closer together. Yeah. Next one. And this is just an example. I'm not going to go into too much detail, but that R is the reliability, human dependency, alignment, and what's the last one? A. What is that AD? I forgot what it's the summary for, Calvin.
Sorry, what was that? You got human dependency, robustness, alignment,
that's it.
Adaptability.
Adaptability, yeah, that's right. So, and you can see from the colors there, I mean, obviously the rates are way too low. So in the case of Macondo, I'll leave it for you to go through the details. But if you did have a CEA process and you did get the experts and the frontline guys together and give ratings, it's highly likely, we think, that upfront you would have seen that that some of these critical controls are not up to performance. Because remember, in the Macondo case, everything looked perfect. Green ticks, green dashboards. The executives thought because they had 7 years incident-free that they were running the perfectly safe system, but there was pressure on people in the front line from a production point of view. Information didn't travel. So all of those things we believe could have been addressed with something
even
like,
falsifying results.
Exactly. There was exactly. And I mean, we understand why that sometimes happens if there's, especially with contractors, they are under pressure to deliver, and the carrier of the messenger the messenger often gets shot. Where this method, the way we try and implement it, it keeps it de-identifies everyone, so information can travel to where good decisions can be made on it. Next one. And here we have the same situation with the Port of Auckland. The CEO, the missing test was whether the exclusion zone actually held during crane operations, and we're speculating, we weren't there, but from what we've read about the case, we believe that from the front line, there would have been the possibility that the critical information around what was workers done like would have come through. And because it was not a case that the CEO was not interested in safety. He put in, as far as the commission said, commendable effort. He put in extreme hours and money to try and get a safe situation. It's just that it failed on the assurance part. And that you can't force on people without a system that gets that information through in a de-identified fashion. Next one. So to be able to show that you've done due diligence, you need to convert these activities, information that you've got into evidence that shows that you have it under control. You are very good at the last 3 sets on the due diligence. And we believe that it helps you a great deal to do exactly that. Yeah, I don't want to read through all of the details. Again, I can just go on the highlights. So the operators score the controls. They interrogate the diversions between workers intended and workers done. And we document these findings, and it's traceable. And I don't see what you can do more than run a control effectiveness assessment when somebody puts you to the test and say, show me that you had control over what was going on.
Yeah, I think just our last slide, we're going to open up to discussion, and this came out of an example that we did. And this particular one was looking at GPS monitoring of drivers, and such. The subject matter experts identified the control as identified as a robust control, and their view was a well-designed and useful control. When we're talking to the frontline workers, it was very different, because they had an experiential view of the control, and in their view, they saw the control as a way of running disciplinary action against them. They felt that it made them concentrate more on dashboards than their driving activity, and the experience was there was a significant amount of these controls being disabled in vehicles as a result, and therefore the control was not doing what it was intended to do. So even a well-intentioned control needs to be understood in its human factors component, and that needs to be managed in the control effectiveness space, is working out how do you actually make that control work and deliver what you're seeking to deliver. But
Calvin,
yep.
If I can just add one more thing. What was also very interesting is that they felt that driving in hilly, windy roads made them look like poor drivers, where those that had open road to drive on, there was no need to brake or to change speed or anything like that, or stop for animals crossing the road. Suddenly, it gave an unfair comparison as to their abilities as a driver, etc.
Yeah, one size doesn't fit all in
Yeah.
the control space. Okay, thanks. We're going to pause there. Look, very keen to have any questions or discussions. There's certainly elements within that we present, we know, that are controversial in many ways. I have tried to bring a focus back into the energy damage model and understand its place, and it's not a new thing. It's actually a thing that's been around for decades in that space. And also, we've been really keen to spawn and conduct debate around our ideas around controls. The problem we have as safety practitioners is the lack of scientific definition about what we do and don't do, and a lot of it is based around practice and experience. Anyone want to ask a question? Yep, go for it, Jody.
Yeah, I'm just interested in that conversation just then around in-vehicle safety systems and telematics. So my take on that is that it doesn't mean that control itself is bad or wrong or poor, but it's very much about how you implement the control with the workforce, right, and as an organisation, how you respond to the data. Right. So it doesn't really mean, oh, well, the workforce don't like being monitored, we just won't have that as a control because it doesn't work, but it's about how you work with them. Because I've seen IVSS implemented very badly, yeah, like what you've just described, and then I've seen it implemented really well, and it becomes almost something that the workers like to have, because it demonstrates, actually, I've got forward-facing cameras and you can see that I'm driving on a windy road, or you can see that I braked for a kangaroo. So you're not going to respond with punishment because I had a harsh braking indicator on my RVSS. So is it more about, it's not black or white, wrong or right, how you implement controls and understanding the gap?
Yeah, because, and this is what, probably, it's a good example because it's common across many things, but yeah, a control can be a great idea, but execution can make it a terrible idea. And so that in control effectiveness, it's about getting the reality of that view in that space. You know, so that's what we often miss. And the other thing that happens in a lot, particularly if we've got more AI-based controls and the driver space, this is happening a lot, is we're getting supervisors and managers drowned in breaches, right? Yeah. It's just like every hour they're getting breaches that they need to respond to and they can't.
Just noise,
So, and this is, I suppose, what we're trying to highlight in the space is we need to improve the balance for subject matter experts, which have a range of different people in that space, right? Is they often have very good and useful technical knowledge, but they might be missing the wider perspective in that space. So what we're saying is really important to get them better intelligence and to make controls work. I think, Sanad, you got your hand up.
Yes, thanks, Kelvin. Great point by Jody as well. And I'll live through this experience. And coming off from the tools, I always think about the end user, right? How can we simplify? And the other part where I think about, can we make this more simpler, is English is not my first language, right? So the context is really important. There are really academic speakers, and you know, we forget that the frontline workers, they're focused on delivering the work and they're brilliant at what they do. But when we release a guide document or critical risk or anything that they need to read, it's just a whole lot of gibberish, right? And we probably need to start influencing, realize that we need to influence stakeholders at higher levels to understand and educate, I suppose, to understand, okay, we have these ideas for these controls, but we need consultation with frontline workers and we need to hear they express them as concerns, right? And sometimes they are, and sometimes they're not validated. That's really my 2 cents.
Yeah, no, it's a really good points. And the other thing is, you sort of touched on it, but comes to me also is that when we look at control effectiveness and putting it in place, this does not make, I suppose, the life of managers and executives easier. It makes it harder, because in what we're doing in that space is we're actually showing them the reality of the work and that the decisions that they make have an impact. And so the status quo is a decision for them, or doing something different is a decision for them. But in their previous world, they could just be satisfied with, we had a control and it's in place. They didn't have to accept the quality of the control might be relative to the amount of investment they're putting into that space. So Matt, you're up, mate. Oh, you're on mute still, mate. Matt, you're on mute. Yep. Still, yep.
Thanks again, Hendrik and Kelvin. Really great presentation. Love the graphics. You really do a great job in assembling those models that are really important. I just thought I'd add an example of how things can really go wrong by not bridging that gap between operators and management. And that was an experience up at Coolin Island, where they had a pit below sea surface level. I sat next to a geotech on the plane on the way back because it had a really steep incline, steep face. And to me, when you look at it, that's the first thing that you worry about, rock falls and slippage, etc. So they were digging below ground level, surface sea level. It's on an island, of course. The workers that I met and the supervisors were concerned about leakage through the wall between the pit and the ocean. They raised it with me. They said they'd raised it with supervisors and middle managers. They were ignored. 8 months later, that wall collapsed, flooded the pit, and they were all out of work. And I was at the mine closed down. They managed somehow or other to get insurance cover about a year or two later, which I thought was pretty amazing. But it shows you there was an SME there, the geotech, certainly they were focused on the most obvious problem, rock falls, but they were blind to this insidious erosion through the sea wall. So they weren't looking at the right things. They seemed to want to brush off the fact that this wall between the ocean and the pit was vulnerable.
Yeah.
So there's a few connections there that even with expertise and knowledge are just ignored, you know.
It goes to, and this is the real question for us in this whole process, is making sure you have the right expertise, but that right expertise is often people who are experienced on the ground, you know, who we don't normally consider as experts, but they're the ones who know the environment, know the land, know what happens in that space. They often don't get into the room.
Yeah. It was unfortunate because they loved the island, they loved the camp life, they had a great culture. So in a way, that was sort of a deterrent to reporting and escalating this potential risk. And they obviously don't feel competent in making a judgment about something that could have a catastrophic failure. So it's somehow getting the right people around the table and getting that message through to the highest level, the C-suite, as you noted in your slides. Yeah. Anyway, fabulous. Thanks for the talk.
Thanks, Matt. We're just about to close up. It's been really great. We have had really good attendance through this. We will be putting out a summary of this session after we've spoken. We'll email that out to you. That'll be in the form of a short video. Please fill out if you want any more information about what we've talked about. Please feel free to reach out. What we're trying to do is spread the word and encourage thinking about how we understand hazards, how we understand controls, and have a more educated discussion about effectiveness and how we understand effectiveness. So thanks everyone, and really appreciate you taking the time to have this discussion with us.
Thank you very much.
Thanks, Kelvin. Thanks, Hendrik.
Thanks.
Thank you.
Thanks.
Thanks. Thanks, Nancy.
Where is the? Oh, there it is. Go on.